Hi, welcome to the session. So in this particular session, we are going to see series data structure in Pandas. So what is a series? A series is a one-dimensional data structure which can hold any type of data. As you can see in this particular figure, we have a series here. So we have data here, Sandra, Neba, Mariam, Shifna, Primal. Instead of this particular strings, or we can say object, we can have integer also, we can have float also. Fine. So it has two things. One is the data, another one is the index. So index is 0, 1, 2, 3, 4. So this is the index. We have like a list, it has index. So series also has index. So this is a positional index we have. So I will tell you about what is a positional index and what is labeled index later. So we have here data and the index. Okay, how to create the series more we will see now. So more about the series, how to perform operations and all we are going to see later. Fine. So let us minimize this. Let me go to our spider. Let me create the series. Okay, creation of the series can be done by a list, dictionary, scalar value or ND array. So I have a notepad here. So I have written how we can able to create the list. Like we can create the list from the list, we can create the list from dictionary, we can create the list from scalar value and ND array and an empty series. So let us see one by one how we can able to create this particular series. Now let me go to my spider. So in this particular spider, let me copy this, the first one. Okay, we are doing the first one. So creation of the series from list. So let me tell you what exactly a list is. Okay, let us take a list 1, that is list 1 is equal to, so let me give the values for the list 1. So that I can give the values here 10, 20, 30, 40. Fine. So these are the values. Let me give another one, 50. So if I print this one, let me close my console. Let me arrange this. Okay, that if I print this one, print list 1. So what we are going to get? So we are going to get a list over here. So as you can see, the way in which we have given a list is a which contains a set of values enclosed in square bracket. Fine. So we got the same thing. We can give any type of value, any type of data type over here. Fine. So let me create the series over here. So before that, I need to import Pandas as PD. Okay. So this is a Pandas library where we are going to use the series method to create the series. Fine. So let us take one variable called S1 is equal to, you can take any variable name. So the PD, we are going to use this Pandas library, PD dot, we have a series method. We have a series method. So I can use this series method, then I can give the values. In the sense, let us give the list that we created over here. Fine. So let me print this S1 and check what we are going to get. Okay. So series is a method used to create the series actually. So we are passing the data, that is we are passing an argument called list1. Thus this particular list is being sent to this particular series method. In turn, series method will create a series and that will be there in the S1. So we are printing the S1. Let us run this one and check what exactly we are going to get the output. So you can see here, this is our list, fine, and this is our series. So let me have a separator over here. Let me, after print statement, I can say here print. Let me have a separator. Okay. And let me run this one. Fine. Now we have a series over here. Sorry, we have a list over here and we have a series over here. Series contains what? Two things. One is the data, another one is the index. So this is called positional index. This is positional index. By default, it will give the indexes. So, and it is of what type? Data type is integer. Fine. So let me create another list. I can change this particular which one? The indexes. I can give my customized indexes, that then it will become a labeled index. So what I can do is I can say here list 1 comma, I can mention, let me type here index equal to, I can mention here A. So I can say here B, then I can say here C, then how many values we have? 5 values we have. So I need to give 5 indexes. So D, then the last one, the E. Okay. So we have count this 1, 2, 3, 4, 5 and we have 5 values. So it should match. Fine. Now let me run this one and check. So what we got here, this is our list. Fine. This is our list. Then we have the series over here and you can see we have A, B, C, D, E, the index that we wanted. So we have given over here. So inside it will be having a positional index 0 to 4 will be there as we have seen. Okay. It will be like this will be 0. So this we'll see later. Fine. So now what we have done, we have created a series from what? From the list. So we have a list data structure. Okay. So by using this list data structure, we created a series S1. So series S1 is what? It is the combination of index as well as the data together we have joined together and we are storing the value. So why we need to do that one? So we can perform many mathematical operations on this, so that we are going to see later. Fine. So let me go to the next one. Let me create a new one. Let me remove this from my spider. Fine. So let me go back. Let me go to the notepad and we have from the dictionary. Okay. Let me minimize this here. So creation of series from dictionary. So first we are going to create the dictionary. So let me create a dictionary over here. So dictionary data, I will say data is equal to, dictionary is what? A key value pair. So key is there and the value is there. So let me give the key here. So the key, let us take, I will give normal, like same way I will create. So whatever I have created here, the same thing I am trying to give. So the key is, I will give key is A, then the value is 10. Fine. And similarly, I can mention the key as B, then the value is 20. So key value pair. So C, then the value is 30. So similarly, I can mention D and the value is 40. Now last one, and we have E, then we will give the value is 50. So we have given the key value pair. Okay. Now here there is an error because we said equal to. So we should not say equal to, we should say colon. Now let me print this dictionary. So what is a dictionary? Dictionary is a key value pair. Okay, data. So let me run this one and you can see the way in which we created, the same way we got the dictionary over here. So dictionary is enclosed in a flower bracket. You can see this is enclosed in a flower bracket and it has key value pair. Fine. So from this also we can able to create the series. Let me copy the separator so that we go back. I'll have a separator over here. So I will say separator. Fine. Now let me create a series now. I will create series S2 which is equal to, I will say PD, our Pandas library, where our series method is there. So I'm going to call the series method. So from this particular series method, in this particular series method, I will give the data. Fine. The data that data is what? It's our dictionary. Fine. So that dictionary I'm going to give here. So I'm going to create a series. Let me print S2, capital S and 2, and let me run this one. So we have a error over here. Let me run this and check there is any error. Yes, we have PD is not defined. What happened? We did not import Pandas as PD. Let me keep only Pandas. I can say Pandas as PD. Okay, it's going to run. Fine. So we created the series from dictionary. I can say Pandas only here, and I can mention here Pandas. The same name, whatever we are giving. Actually, let me run this one and to show you. So we get the series over here. Fine. Now, what is this PD? As PD. So this is an alternate name we are giving for the pandas. So I will give here PD. So I'm going to use PD over here. So since I have used alternate name, I must use alternate name over here. It should not be the reserve word or the keyword. Okay. So I have given PD. So I'm using this pandas and I'm going to create a series by using dictionary. So this dictionary key value pair has been converted to a series. So the key has become a index and the value has become here the data. Fine. So and data type is what? Int type. So we successfully created series from dictionary. Let me go back. Let me take the third question from the scalar value. So let me copy this and I'll go for a new file. Let me remove this. Okay. What I will do is I will import pandas as PD. I will copy from the previous one. Okay. And I'm going to paste over here so that I should not type again. So then what I will do is I need to scalar value, right? I need one scalar value. Let us take data is equal to, let me take here 100. Fine. 100. Now I will create the series from this data. Okay. So what I will do is I will say here S3 is equal to a series, new series. I am going to create PD dot series. Then I will give data. Okay. Let me see what is going to happen. Print. So it did not say any error. Okay. And I will say here S3. So let me run this one. Let me close the console and let us run this one here. And you can see it has given automatically, it has given the index as 0 and it is 100. So it's going to create a key value, it's going to create index and the data. By default, it has given 0. Now, why data is 100? That's why we got this one. Now, let me add up something over here. I will say index equal to, let me give here A. I will give 3 values, okay? 3 indexes I will give. A, B, then I am going to give C, okay? Now, you can see here data is 100. This is scalar value, 100, but I am giving 3 indexes. So, what's going to happen? So, since now the list we have given, if you see the list, let me go back to the list and this is the list, right? We have 5 data values, okay? Then we have given 5 indexes. Now, here I have only one data, right? The value is only 1 here. Then I have given 3 indexes. So, what's going to happen? Let me run this one and see. And if we create from this, see what happened? A, B, C, these are the indexes that we have given. And it has copied this 100 to all 3 indexes values. Okay, the data of this particular indexes B and C will be 100. So, if you give like as many as indexes, it's going to copy this 100. So, this is called creation of the series from scalar value. So, we have to be very careful here while creating this series from the scalar value. Okay. So, let me take a new one. Let me remove this from my spider. Then I will go back and check what is my next. So, let me create series from ND array. So, let me copy this over here. Let me copy my import pandas as PD. Okay. Then let me paste over here. Then what I will do is I am going to import numpy array. Okay. Import numpy. This is another library that I am going to import, numpy library. So that is NP. So if this will be useful when we want to create numpy array of similar data type. So let us say data is equal to, so np dot array. So if we are very sure that it is 10, 20, 30, 40. So let me give this in this way. Okay. So this is a numpy array, okay, of similar data type, which holds similar data type. The difference between numpy array and our series is, series has you can give any type of data over here. Here some different data types. Now here which holds numpy array holds a similar type of data. Now we have given it should be int only. Fine. Now if you give string here by default, now it will convert all the things to be string. Okay. Now let me come here and create. That means let us say S series S is equal to. So I can say here PD dot. I am going to create a series. In series is S capital. Please note. So we are going to make mistake here S capital. So then I will give here data. So let me print S. Okay. So if I print S, let me run this one. Now you can see you can create the numpy array is this 10, 20, 30, 40. So it has created a series from the numpy array. Okay. Now let me go to the last one. So what is the last creation? Creation of empty series. Let me copy this. Okay. Let me copy my pandas, import pandas. So after this, what I will do is, I will not have any data. Let me create series S is equal to PD dot series. Okay. Series. Then I will print S. Okay. Let me run this. I can see we have an empty series over here. Okay. We are not going to give any data. We just created an empty series we have created. Okay. So if I print type of S, okay, let me run this. So you can see here, so it is of type series type. So earlier we did not had that one, and by default the data type of empty series is float. Okay, data type is float by default. Okay, now in this way we can able to create series. Now let us create a series of string. Let me take a new one. Now I can create a series. Let us say, let me copy this import statement. Okay. Now let me create a series. Let us take the data. Data is equal to. So what happens if I give something like name like Neba? Okay. I'll take three data I will take. So I will take Zahra, then I will take Fatima. Okay. Now let me create series. Okay. So S is equal to PD dot series of. So I will give data. Okay. So let me print this. Print data. Sorry, print S. We are printing series. Okay. So let me run this, and you can see we have created, and data type you see it's an object. It is not, now it is not integer because we have given this as like a string type. So by default if it is a string, it's going to give as object. So this by default it has given the index like 0, 1, 2. So let us say we don't like this 0, 1, 2. I can still give numbers instead of index like ABC. I can make like 1, 2, 3. So let me run this. If I run this one, you can see 1 Neba, 2 Zahra, and 3 Fatima. But inside it will be positional. This is the labeled index. Now we change it, right? So this we call it as a labeled index. So inside it will be 0, 1, 2, 3 will be as it is. Fine. So this is 1, 2, 3 is a labeled index. 0, 1, 2, 3 will be there inside. That is called as positional index. Fine. Now this is one way. Let me go back. Let me create a new one. So let me copy import pandas as PD. I'll show you another method that may be useful. Let us take a string. Okay, str is equal to, let me give as Rizwan. Fine. This is my name, and I can say, let me create a series from the string. How to create a series from the string actually. Fine. Now what I can do is, I can take a list. L is equal to, I can convert this to a list. I can convert this to a list, str, then list of str. Let me print L. Okay, let me print L and check what happens. This is the list. L is a list. So you can see it has successfully converted this Rizwan to RIZWN. This is a list values. So list values we got. Now L is a list. We are creating a list. We are converting list from the string str. So Rizwan will be converted to RIZWN and it will be given to L. So L contains a list. Now from this you know how to create. Just now I told S is equal to PD dot. So now I can able to create series, and I can give here L. Let me print what S series I am going to print. Let me run this one, and you can see RIZWN. These are the data, and 0 to 5 is the index. So if I want, I can change the index. So how to change the index? I can say here index equal to, I can mention any index. Okay, I can mention any index. Let us say 10, 11, 12, 13, 14, 15. How many are there? Yeah, 10 to 15 I have given. Let me run this. So it should match. The number should match. There are 6 are there. The 6 characters are there. So 6 indexes I need to give. So if I run this one, and you can see the indexes have changed to 10 to 15. This is a labeled index. Here if we give the index, labeled index, by default it will give positional index. The positional index also will be there, that we are going to see later. Okay. Now let us see how we can able to access the elements of the series. So we call it as a indexing. So this we have 5 types we can use. One is the labeled index we can use. We can use positional index to access the elements. The third one is the Boolean indexing, or we can say conditions, that we are going to see. Next is slicing. We can use slicing. Then finally we will see lock and ilock methods. So before we go into the labeled index, let me show you this particular series. In this particular series we have like A, B, C, D, E, F. These are the labeled index, and data is 10 to 60, 10, 20, 30, 40, 50, 60. This is the data. And positional index, even though we have given the label index as like A to F, but inside the positional index will be there 0, 1, 2, 3, 4, 5. Okay. So let me minimize this. Let me open my notepad, and we will see the first one, that is labeled index. So how to access the elements? By using labeled index. Let me go to my spider. Okay. Let me run this one, and this is the same series that we have created earlier. So we have the series from the dictionary. So we have created the series from the dictionary. We have 10 to 50 in this particular thing. Now let me do the labeled indexing. Okay, how we can able to do the labeled indexing? So labeled here is A to E. This is the labeled index. Say for example, I want to access the element 30 only. So how can I able to access? So the labeled index associated with this is C. So I can able to say, so name of the series is S2. Okay. So let me print. I have to use small letters. Print. Let me write here S2 of, what is the labeled index? It is C. Okay. So small c I will give. Let me run this one, and I can see it's displaying 30. So let me use one separator over here. So let me write print. So I can use this. So I will use this print statement after my printing S2 here. Okay. So let me keep it here. Now let us run this one, and you can see here, this is my series, this is my dictionary. Okay. Then 30 it is displayed. So what is this 30? We have used S2 of C. So S2 of C, this is going to this is the labeled index we have used, and we can able to access 30. Fine. Now let us go to let me minimize. Let me go to my notepad. Next one is positional indexing. So how to use positional indexing? So as I told positional indexing, let me write that positional index here. I need to use display 30 again, but not using labeled index. I need to use positional index. So let me go back to my image, this particular thing, and you can see C30. What is the positional index? 2, right? 0, 1, 2. So 0, 1, 2. The positional index is 2. Okay. Let me minimize. Let me go back here. Then I need to say what? Print. Okay, I have to type here. Okay. Print. I need to say S2 of, okay, 2. So this is my positional index. Let me run this, and you can see it has displayed 30 by using this positional index. Fine. Now the last one, the next one, let me run this one and I can show this is the dictionary, this is the series, and we got from S2 of C is 30 and S2 of 2 is also 30. So you might be wondering why it is C, why it is 2. As I told in this particular image, 2, we can use positional index 2 also to display 30. Fine. Now the next one, let me remove this two things, labeled index and positional index. Let me open my notepad, and the third one is Boolean indexing, or like conditions or comparison operations. So this all three are one and the same. Let me copy paste over here. So let me use comment for this. Okay. So comparison operations. So let me write here. Let me take up here. Let us say one S I will take. S is equal to, I can say here, what I can say is S2, the name of the series S2. Let us say I want to display 30, okay, again this one, fine, I want to display by using Boolean indexing. S2 is equal to 30, okay, S2 is equal to 30. So when I say this one, wait, let me print this one. Before that, let me print S2 is equal to 30. Now just see what will happen when I say this one, print S2 is equal to 30, and you can see what we are doing is S2 is equal to, is S2 is 30 the first one element? No, right? False. Second one is 30? No, false. Then third one, you can see, is it true? Is S2 is 30? Yes, right? So that's why it is true here. Now the next one, you can see it is false. It is also false. So it's going to display true or false based upon the values over here. Fine. So this we got like S2 is equal to 30 when we say this one. So you are comparing each element with 30. Now what I will do is, I will use separator here. Okay. Then what I will do is, I'll copy this statement. Then I will use S2 outside. Inside this bracket, I will say this S2 equal to 30. Now just now we saw S2 is double equal to 30 will give true or false, correct? Now this will give true or false. Now this will say this one is false, correct? This one is false, this one is true, then it's going to display this one, right? Let me run this one, and you can see it has displayed what? C30, okay, C30. So first it's going to compare this one, it's going to compare this one. Is it 30? False. Is it 30? False. Now this is true, right? So then it will display this one. Whichever it is true in this, for this particular condition, S2 is equal to 30, whichever the condition is true, whichever the value is true with this particular S2, then it's going to display. Let us say we have S2. S2 is what now? 10. 10 equal to 30? False. So it's not going to display the first one, first row. Now second one is 20 is equal to 30 here. You can see 20 equal to 30? No. Now next one, 30 is equal to 30? Yes. So it has displayed this one. The others will not display because it is not equal to 30. Now in this way, I can able to get the values. Say for example, let me remove this. Let me have a question, something like this. Okay. Say for example, I want to display. Let me run this. So I'll make sure. Let me close the console. Okay. To have a fresh startup. Let me say for example, I want to display greater than 30. I want to display the elements which are greater than 30. You can see this 30, like 40 and 50 only it should display. So what I will do is, I will write here S2. Inside this one, I will write a condition S2 greater than 30. Now when I say this one, let me run this one. and you can see check the condition S2 greater than 30. This is S2, fine, first element. Is it greater than 30? False. No, it is not going to display. This one, false. This one, false. 30 greater than 40? No, false. 40 greater than, 40 greater than 30? Yes, so it has displayed. Then 50 greater than 30, it has displayed. So what we are doing here is we are using this is called Boolean indexing. By using Boolean indexing, you can able to display the elements. You give the condition, or we can say here comparison operations. Fine. Now similarly, I can give something like let us say S2 is equal to, let us say here I want to display only 20 and 40. Okay, S2 is equal to 20. Then I will say here or S2 equal to 40. Okay, let me run this. I need to use single. Okay. Now you can see. Now what I have done here is I have given the condition. Two conditions are there here. So I have given OR operator in between. So is S2 is equal to 20 or S2 is equal to 40. So two conditions I have joined by using OR operator. Okay. So this one, is it S2 greater than 20? No. Is it S2 greater than 40? No. Is it S2 greater than 20? Yes. So it's going to display. Fine. Now this one, this is true. Okay. Now if you take 30, is 30 equal to 20? No. 30 equal to 40? No. Similarly, it's going to check whichever the condition is true, it's going to display that particular, any one condition should be true because it's a OR operator. Fine. Now let us take something like this. Let us say I want to display between 20 and 40. Okay, I want to display between 20 and 40. So what I will do is I will say here greater than or equal to 20. Okay, and I will use AND operator here. Fine. Then I will say S2 less than or equal to 40. Okay, let me run this, and you can see it has displayed between 20 and 40. So what is the thing we have used here? Is S2 greater than or equal to 20 and S2 less than or equal to 20, less than or equal to 40. So it should be between 20 and 40. Okay, the first condition will be applied here. Now instead of S2, you just keep this 10. Okay, this 10 you keep it here. Okay, is 10 greater than 20 or equal to 20? No, right? Then no need to check the other one because it's an AND operation. So AND operation, what happens if both the conditions should be true? Now next you take 20. Is 20 greater than or equal to 20? Yes. Okay, this is true. Then is 20 less than or equal to 40? 20 is less than 40. So it's going to take this element and it will display here. Similarly, this one, this also will fall between 20 and 40. This also will be, this 40 also will be within this range 20 and 40. Now if you take 50, is 50 greater than 20? Yes. But is 50 less than or equal to 40? No, right? So this condition fails here. This condition failed for 50. So that's why it's not going to display. So this is AND operation. So in this way we can able to have Boolean indexing or conditions and we can able to display we are extracting basically what we are doing, we are taking, we have a series and we are taking the values based on certain condition. If that condition is met, then we are going to extract. Okay, that's what like Boolean indexing does. Fine. Now let us go to the next one. Let me remove this. Okay, let me take the next question from the notepad. Next one is slicing. Let me copy this slicing. The fourth one we are doing now, slicing. Okay, now let us say I want to print my series is S2. Then if I say colon, okay, let us take from A to D. Okay, so from A to D, colon means to D. Okay, colon means to A to D. Okay, let me run this and you can see A to D, it has been printed. I can change this B here, B to D, fine. So let me run this. Now you can see B to D, okay, B to D. So let me remove this print statement. This I don't require this every time dictionary to be displayed. Let me run now and you can see we have a series and B to D, it has been displayed. Now I can do like this. What I can do is if I remove this one, okay, the ending one I am not giving, the starting position I am giving, the ending position I am not giving. So at that time what will happen is it will display till the end. So it will start from B till E, it will display. Okay, let us run this one and you can see B to E it has displayed, even though I have not given here. Let me give here now D, then I will remove the first one. So if I remove the first one is blank. That means it's going to take them from where? From A, because we have not given any starting index. The ending index we have given what? D we have given. So it will display till D. From A to D it will display. See, please see that. So A to D it has displayed, even though we have not given. If you remove both, let me remove this. Okay, and you can see there is no starting point and there is no ending point. At that time it's going to display the full series from beginning to end, it is going to display. Okay, now this is about slicing. Now let me give like we have slicing for let us say 1 to 4. Okay, 1 to 4, position 1 to 4. Now let me run this and I'll demonstrate what exactly I mean. Now this is 1 to 4. Okay, so if you see this one, 0, 1, 2, 3, fourth one will not be displayed. Okay, so let me go back to my image. Sorry, this is not my image, this is the image. 1 to 4. So you can see 1, 20, 2, 30. Okay, that means C30. Then D40 we got, but fourth one will not be displayed. Why fourth one will not be displayed? One less than the whatever we have mentioned. So this we have given 4. This is we have used what? Positional indexing. When we use slicing with positional indexing, okay, then one less than that one. If you use labeled indexing, no problem. It will display, let us say A to D. It will display A to D, no problem, right? Now here we said 1 to 4. So it uses positional indexing and also it will make sure that one less than this one. That means what? It is going to display 1 to 3 only. Okay, that is positional indexing. That means let us go back to my particular image. 1 to 4 means it is going to display 1, positional indexing 1, not 0. Okay, not A. Okay, 1, 2, 3. Fourth one will not be displayed. So one less than that one. Okay, so let me change here. Let us go 2 and let us give 5. Okay, so what happens? 2 to 5. Let me open my image. 2 to 5. Okay, 2, 3, 4 only it will display. The fifth one will not be displayed. Okay, that means C, D, E it will display. Okay, let us run this one and you can see C, D, E it will display. So this is 0, 1, 2, 3, 4, fifth one it will not. Fifth one is anyway it is not there at all. Okay, so in this way we have slicing. Slicing depends on whether you give positional index or label index. It's all depends on that one. Okay, now let us go to the next one and let me go to the next lock and iLock method. Okay, let me copy this. Okay, let me remove this. Okay, I have lock method and iLock method. So let me print. See, sometimes it is very difficult to understand between the labeled index and positional index, which one it is using. You may get confused, right? So what I can do is I can say s2 dot. If I say lock method, I had to make sure that I need to give labeled index only. Lock method makes sure that, say for example, if I say B inside the single quote, okay, or double quote. So if I say this one, it's going to display what? See this one? B means 20. Fine. So I can give 2 brackets here. Okay. So then it's going to display what? Index also. If I give two brackets, so B20 it's going to display this one, right? Now if I same thing, if I say 2 here, okay. Is labeled index contains 2? No, right? So then it will give error. It should give error now. So it's going to give error because even though you think that, okay, fine, this is a positional indexing I am giving. What I am talking about this positional index, you think that you are going to give this 2 and you will get 30. No, because lock method makes sure that whatever the labeled index is there here, that only it should exist. You cannot have outside these labeled indexes. So that is lock method. Fine. Now I can give here, let us say C. Okay. So if I say C now, you can see first one is B 20. Fine. Next one is C. So C 30. So it has taken B and C. So what happens like if I give something like this? Let us say I will give, you might be thinking that I can give like this. Is it possible to give like this? Let me run this one. It is possible. So you can get B comma C like this here. Fine. What about the direct method? Direct method can we give like this? Let me copy this. Direct method in the sense without lock method. Without lock method. Let me remove the lock method. Can I give like this? Let me run. Okay. Then also you are going to get same thing as lock method. So lock method you can use. You can mention 2 indexes at a time or 2 or 3 indexes at a time. Fine. This is lock method. You can mention the slicing also. Let me remove this if it is getting confused. So many things. Let me write here print s2.lock lock of. Now I can mention from B to C. Fine. B to let me take B to D. Okay. B C D. Let me run this one, and you can see B C D. B C D. So you can use like direct method also, or the lock method you can use to get to use the slicing. Fine. The same rule applies. If I remove this one, B to the ending position I have not given, so it will display from B to E till the end. Fine. Now this is lock method. So then what is this iLock method? Let me write that iLock method s2 dot iLock s2 dot iLock of 2. So let me go to the image. iLock of 2. So I have to give the positional indexing. The lock method, we must make sure that we have to give the labeled indexing only. Okay. Lock method make sure labeled index only. Whereas iLock method, we have to give the positional index only. Let me run this one. So you can see 20 it is. So this is 0, 1, 2. So C 30. That is, if I give double bracket, so it will give C30. Let me run this one now, and you can see C30 has been displayed over here. So similarly, like I can say 2, 4. If I say iLock of 2, 4, so you can see this is 0, 1, 2. This will not be displayed, and this is going to be displayed. Okay, 2, 4. Now this is called iLock method. Now what happens instead in this? If I give labeled index, okay, let me say I will give the labeled index here. What happens? So it will give error. Why? Because I said iLock method. iLock method, we must give positional indexing, not the labeled index. Okay. For lock method, only labeled index. For iLock method, only positional index. Okay. Now I can give this for slicing I can use. For slicing inner bracket, I don't have to give. Let us say I will give colon. That means it's going to display this for this series. This is the output. For this one, we got this one. So you can use the slicing. Let us say you can say 1 to 4. Okay, let me run this. So you get, see this one, 0, 1, 2, 3. Fourth one will not display. We know that, right? So 1 less than this. That means 1 to 3 it will display. Okay. So iLock method. So you can see this one, 1 to 4. 1, 2, 3. Fourth one will not display. So that means B to D. So 1 means don't take this, the first one. This is positional index always starts with 0. Okay. So in this way, we can use lock and ilock method to access the elements of the series. So you might be wondering if what happens if I give 1, 2, 3, 4 here. Okay, so let us do that one. Let me copy this. Let me take the same the series. Let me copy this. I'll take a new one and print. Instead of A, I will give 1, and this I will give 2, and this I will give 3. Then I will give, instead of 3, I will give 3, 4, and this I will give 5. Okay, let me run this, and you can see 1, 2, 3, 4, 5. So now this is my labeled index. Okay, and 0, 1, 2, 3 will be there as it is. Let me show my here. Next, I will go to the next slide, and you can see this one. This is what we are talking about. Now you can see 10, 20, 30, 40. This is the data, and we have labeled indexes. Fine. 1, 2, 3, 4, 5. Positional indexes. Positional index will remain 0 to 4. So lock method will uses this particular labeled index, and ilock method uses this positional indexing. So you have to be very careful. Try with this thing. Okay. Try this data frame and try to, let us say for example, I want to print S2 dot lock of 2. What do you think? What it is going to print? Okay. And you can see it's going to print. I will give double bracket so that I will make sure. Okay. Let me have a separator. Let me run this one now. Now you can see 220 it has displayed. Fine. Because it's going to use the direct labeled index it's going to take. Fine. Lock method. Now same thing. Let me copy this. I will use ilock method. So what do you think? What it is going to print? Let me run this one, and you can see it's going to print 330. So 220 for S2 dot lock. Fine. Because it's going to take the direct way, and 330. Okay, even though we have given 2, why it has taken 3? Because 0, 1, 2, okay, this is the 1, this is the 2. So let me go back to my image and show you. If you see this one, 0, 1, 2 is actually 330. Fine. So it's going to take the positional indexing. It's not going to take the labeled indexing. Fine. So even though you have given 2 here, it's not going to take this one. The inside positional indexing, whatever it is there, 0, 1, 2. That means 330 is going to display. Hope you understood this particular concept. Okay. Next, we can go for head and tail methods. Okay. So let me check what is this head and tail method. So let me minimize this, and let us go for our spider, and we have a series here. So let me run this one. So you can see we have a series with index A, B, C, D till E, and we have the values 1, 2, 3, 4, 5. So we have like series we are creating from the list 1, 2, 3, 4, 5. Fine. And we have the indexes A to E. We are providing indexes and we are creating PD dot series. So this is a series we are creating from the list. Fine. So let me check what is this head method. So in this head method, what I will do is I will try to print S dot head of 2. Okay. So what I will do is let us say, so what head of 2. Head of 2 means it is going to take the first 2 elements. Okay. It's going to take first 2 elements. Fine. So similarly, we have tail method. So print S dot tail method. So I can mention here. Let us run this one. Capital S it should be. So I will get last 3 elements. Tail will give last element. Let us have the separator in between these print statements. So let me run this, and you can see this is the head method will give the first 2 elements. This is the one. The tail method will give the last 3 elements. So you can see the last 3 elements. It's displayed over here. So head and tail will give the starting. Head will give the starting values, and the tail will give the last elements, like from the end it will give. Fine. So let me add some more values here. Let me say here 6 and let me say 7 and let me add up here like F. Then I will add another one. The indexes should match E, F, then G. Fine. So let me run this. Okay, we got this 1 to 7 and 1 to 7. So the first two element we got here and the last three element 5, 6, 7 we got here. So let me remove this head and tail method, and what happens if I give, like, let us say print, if I say s dot head and I did not mention how many elements. Okay, so what is going to happen? So it will try to give, like it will give the first 5 elements. Okay, so if you don't provide how many elements we want, so it will give what? First 5 elements it will give. So similarly, if I say tail here, so s dot tail, then what happens is it will give last 5 elements. It will give the last 5 elements. Fine. So in this way we can see the head and tail method. Let us say we want to extract starting values or the ending values. So then we can use head and tail method. So let me go to take a new one. So let me check what exactly we have. Next one, let me go to my notepad, change the value of the series element. Okay, I can change the value. So let me go for my, let me copy this particular series to the new file. So let me run this. Okay, we have a series here from A to F, A to G, and we have 1 to 7 the values. So let me change the value. Let us say I want to change this 4 to, let us say 40. I want to change this 4 to 40. What is the index of that? It's a D. Fine. So I can able to access that. If I say print, I will use the, sorry, I have to type here print. I have to say here S. Like how can I able to access this 4? I have to say here S of D. Okay, this is a labeled index we are providing. So if I say this one, so I am going to get 4. So if I give double bracket, it will provide the index also, that we know, that we have seen. Fine. Let me run this. So we got this 4. Now what I will do is I will say here S of D. Okay, S of D is equal to 40. Okay, and let me remove this. I don't need this now. Now I will print S. I will print the series, whole series I will print. Now what I am doing is I am changing this 4 to 40. Fine. S of D is equal to 40. So 40 will be assigned to this particular index here. Here it will be assigned. So let me run this one. So I have problem here. It is small s I have given here, but it should be capital S. So let me run this one, and you can see I have changed from 4 to 40. I have changed. Fine. So in this way I can able to change the value. Fine. Let us say I want to add to the series. Is it possible? So actually the series says we cannot change the size of the series, but we can able to do it. So let me say here, so S of, we have G, right? Let me write here S of H is equal to, let us give 100, let us give 1000. Okay. Now this H is not there, right? You can see A to G is there, H is not there. So what happens if I give this one? So H will be appended at the end. Let me run this one and I will demonstrate here. This is my original series, and what I have done here is I have added this H 1000 to this particular series. Okay. So if H is there here, it will try to change. Since H is not there, so what happens is it's going to change the value of this particular index H. The value will be changed to like if H is there. If it is not there, then it will be appended. So let us go to the next topic. Add new, this we have seen, add new value to a series, that just now we have seen. Now let us see the mathematical operations. Okay. Now in that mathematical operation, we have scalar operation and arithmetic operation. Let me copy this and let me remove this. Okay. And let us have here. Now before I do that one, So I will keep it very simple. The series I will keep it very simple. So I will keep it till 4 and I'll keep it here. Okay. Only 4 elements I will keep. Fine. Now, first I will do the mathematical operation, scalar operation I will do. So scalar operation. So in this scalar operation, what happens is, let us say if I want to say print s multiplied by 2. What happens if I multiply this particular series? What happens? So let me run this one and you can see we have 1, 2, 3, 4 and if you multiply this by 2, all the elements will be multiplied by 2. So s what? If I say s into 2, 2 will be 1 into 2, 2 we got. So 2 into 2, 4, 3 into 2, 6 and 4 into 2, 8. So it will be multiplied. Fine. So similarly, let us say if I add here, let us say plus 2 if I add. So you can see here, now 1 plus 2 is 3, 2 plus 2 is 4. So it is going to add the elements, it is going to add 2 to all the elements. Fine. So similarly, I can do subtraction. So minus 2, let us take, I will give minus 1. Okay. Let me run this one and you can see it has subtracted. Similarly, I can do division, I can do modulus operator. So that you try, fine. So either I can write like this or I can say s is equal to, I can mention here, or let us say I can take a new series s2 is equal to s, let us take, I will change here, let me give here 10, let us give 20, let us give 30, let us give 40. Let me remove this and check whether my series, what I got the series here. So 10, 20, 30, 40. This is my new series now. So what I will do is, I will say here S2 is equal to S divided by 10. Okay, S divided by 10. So if I print S2, what's going to happen? Okay. So we know that this is 10 divided, 10 divided by 10 is 1, 20 divided by 10 is 2. So that will be assigned to S2. Okay. So let me run this one and you can see it's going to give the 1, 2, 3, 4. Fine. So this will be the float. Fine. This is a float. This is, even though this is an int, since we are doing division, so it's going to give in decimal values. Okay. So it is in float. So this is called scalar operation. Scalar operation. So then what is what about we have arithmetic operations? So let me take let me remove this. Okay, I will say here let me write here arithmetic operation. Okay, operation, arithmetic operation. So let me give another series here. Let me keep this one S1. Okay, let me run this. Now we got 10, 20, 30, 40. Now let me have another, this I will keep it S1. Let me copy the whole thing and keep it here. Let me keep this as S2. This I will give like 2, 2, 2 and 2. All the elements in S2 is 2. Let me run this one. So you can see this series S1, I have 10, 20, 30, 40 and whereas S2 we have, sorry, I am printing S1. So I have to change it to S2. Let me run this one. Now we can see this is S1, 10 to 40. S2, all the elements are 2. Okay. Because we have given here. Fine. So we have S1 series and S2 series. Now let us do the mathematical operations. So let us take S3 is equal to S1 plus S2. So what is going to happen if I add up like this plus this, okay, 10 plus 2, what happens? So we are going to add up. So see the indexes are matching. ABCD is the index for S1 and ABCD is the index of S2. So when we add up these two, so the if indexes are matching, so 10 plus 2, 12, 20 plus 2, 22. So it's, let me print this one. Let me demonstrate. So I have given small s, the small s. Now let us change to capital S. Then let me print S3. So let me print here S3 and check. Okay. And you can see 10 plus 2 is 12, 20 plus 2 is 22. So, similarly, it's going to add the elements. Similarly, I can do like subtraction, or I can do multiplication, division, or modulus. Okay. So, let me do multiplication. If I do multiplication, as you can see, 10 into 2, 20, 20 into 2, 40. So, it's going to display. So, the elements will be added. The respective elements of the series will be added. So, you have A, it matches. So, it's going to add up. We have B, then it's going to add up. So, what happens if it doesn't match? So, let us check that one. So, this is addition we can have, subtraction, multiplication, division, and modulus we can have. This is arithmetic operations. So, let me go for, let us take, let me remove this. Let us take something called, we have, let us take only 3 elements, okay, sorry, 2 elements only we will take. So, we have AB here, okay, AB, fine. Now, let me take up this A here, and I will give this, okay, and we will have only 2 elements, fine. Now, let me print this one, okay, let me run this one and check. Now, we have series S1, observe carefully please, 10 and 20, fine, A and B, B and C we have 2 and 2. So, see that indexes, A is there here, A is not here, okay, B is here, B is there, C is here in this series too, but C is not here. So, at that time, let me do the arithmetic operation S3 is equal to S1 plus S2, okay. So, what happens? Print S3, print S3. So, let me run this and I will show that here 10 plus 2 is, no, 10 is here, but A is not there, right. So, what happens? Since A is not there here, so it's 10 plus a null value it will take. 10 plus null is NaN, not a number, fine. So, you get a NaN value, that means not a number, just like a null value in MySQL, fine. Then B is there here 20 and B is there here 20 plus 2, then we get 22, okay. Then C is there here, but C is not here in series S1, so it's not there. So, we will get NaN again. So, if matching values or matching indexes does not exist, then it will end up in NaN value, fine. Now, this is S3, we have only one B because B is common for both S1 and S2, so we get it is going to add up. Similarly, you can do multiplication, division in this. So, even though multiplication if you do, the same thing will happen. So, it will multiply only B and B of this because the other element does not exist. So, that is why it is NaN. Now, how to overcome this problem? To overcome this problem, we have arithmetic methods. So, let me remove this and add the heading as arithmetic. Let me go back here. You can see arithmetic method is the next topic that I have kept here. So, I will say arithmetic methods, then I will say like S3 is equal to S1 dot add S2. Then I will say here, there is one beautiful thing here, fill value equal to 0. You can give any value that I will demonstrate, fill value equal to 0. Now, if I say print S3, now please see what's going to happen here. Let me run this one. Then you can see here 10, even though it is not there, it is 10.0, fine. So, it has taken 0 here. B 20, B is there here, 10, 20 plus 2, it is 22. Now, 2 is here, but 2 C is not there here, C is here, C is here in this S2, but C is not there here, right. So, then 2 only, right, correct. What is happening? Fill value 0. So, it means what? If that respective index is not there, then it's going to fill with 0. Say for example, we have A10, right. Now, here A10 is, A is not there. So, then automatically A0 it will keep. So, that means 10 plus 0 what? 10. Now, here B is there, here also B is there, then it will add up. So, it will not fill the value, okay. Then C is there here, C is not here. So, it will fill C as 0 in the series S1. So, that is why we get this particular 2, okay. Now, let us keep this as 100, okay. So, what happens? 100. So, fill value 100. So, A is here, A is not there, 10, then A will be 100 here this side. So 10 plus 100, 110. So let me run this and show you, demonstrate that one. So you can see 110 we got. Why? Because we said fill value 100. So we have like arithmetic methods. In arithmetic methods, we have add method. So series has the add method. You can able to add S1 and S2 you can add and store it in S3. Fine. So similarly, you can see here, C is here, C is not there here. Since C is not here, so the fill value will be 100. 2 plus 100, it is 102. Okay. Now similarly, like you have, once we have done the add, then you can do subtract. Let me keep this fill value as 0. So subtraction, if we do, check this one, what happens. So 10 minus 0 is 10 only. Fine. Then 20 minus 2, because B is here, B is here. 20 minus 2 is 18. Fine. Then here C is not there, right? It's going to fill up with 0. C is 0. 0 minus 2, that means we get minus 2. Similarly, you can do multiplication. You can do multiplication. If you do multiplication, the same thing, like 10 into, like we have 10 here and it fill up with 0 here, A 0. So 10 into 0, what? 0. Similarly, 20 into 20 into 2. Because B is here, B is here. 20 into 2 is 40. Now C is here, C is not there. 0 into 2, this will be 0. Okay. Similarly, you can do multiplication, division, check the other methods you have, whatever we have. So this is, we call it as a arithmetic methods. So addition, add, sub, mul, div, div is there, division. Fine. So once we have done this one, let me go back to my this particular series. Let me run this one. Okay. Now we have, let me remove some of the elements from this. Only I will keep only 5. Let me keep 5. Then I will keep here only 5. Let me run this and check. Okay. Let us go to the next one. Attributes of a series. So last topic. Attributes of a series. Now let me put that as a heading. So that's attributes of a series. So we will see one by one what are the attributes of a series. Now I can say here the first one, I want to display, let us say only the indexes I want to display. So what is the name of the series? I can say here print s dot index. So if I say print s dot index, I can see here I will display only indexes. So you can see A, B, C, D, E. So it's going to display A, B, C, D, E. Fine. Let us say instead of A, B, C, D, E, I want to change to something like 1, 2, 3, 4. Okay. Let us say 10, 20, 30, 40. I want to change this one. So I can do that one by selecting this s dot index. S dot index equal to, I am assigning the s dot index equal to, so I can say 10, 20, 30, 40, 50. Fine. So then let me print s. Okay. Let me print s. Now I am going to change what? I am changing the index of this particular series. You can see here, even though the original ABCD is there, I have changed to 10, 20, 30. This is my new index. And the values remains as 1, 2, 3, 4, 5 only. Okay. So index is an attribute. By using this, you can able to find out what are the indexes of the series, and also we can change the indexes of the series. So this you can see here we have displayed the indexes. Then after that we change the indexes and we displayed the series. Now this is the first one, is the index. Now next is, I will take it as print. Let us say I want to print only the values. Okay. I can print only the values here. Let me run this one and you can see 1, 2, 3, 4, 5. My the series is A. We have a B, C, D, E index, and 1, 2, 3, 4, 5 are the values. So I can able to print only the values. Fine. That is over. I cannot change the values by using like s dot values is equal to, you cannot say 10, 20, 30, 40. It will give error. So we cannot do that one. Fine. I will not try that, okay, it will give error. So next is, once we have done, I can change this, let me print a series, okay, let me print series name s dot name, okay, s dot name. So what I will get? None. We did not assign any name to this series. So let me assign one name, that is I can say s dot name is equal to, I will say my name called Rizwan, okay. Okay. Then let me print this s. Let me print the series. So what happens? So you can see here earlier here d type int, okay, we have a series and you can see the new series, and what is the name of the series now? Rizwan. So it has displayed the name, okay. So we are setting one name to the series, even though name of the like variable is s here, but we can change the name of the series here to Rizwan here. So earlier you can see nothing is there, fine. Now let me print this like s dot name. So if I print s dot name now it is going to display what? Rizwan only. So you can see it has displayed Rizwan. So let me have a separator so that you should understand what we are doing. So we have a separator here. Now see here, this is the original series. We printed the s dot name. It's not. We printed the s dot name. It is none. Nothing is there. Then we set the s dot name to Rizwan. Then we printed the series. Then you can see a new series with name what? Rizwan. Now we are printing that only s dot name, and you can see we got Rizwan as a name. Name of the series is Rizwan. So we have done with this. Now let me keep this series name, okay, s dot name, fine, as it is. I'll keep this. Now I'll remove this. Let me remove this particular thing. Let me keep it this one here. Fine. Let us run this. And you can see I have a new series. I have a series 1, 2, same series, but I have kept a name. So what is the name here? But I cannot give the name while creating the series. So I need to explicitly say this s dot name equal to Rizwan as an attribute. So now I have a series with name Rizwan. Fine. Now let me keep series dot index dot name is equal to, let us take IIS, okay, IIS, Ideal Indian School, let us say. Then I have to keep it in single quote or double quote. Let me print the series now, okay. So and see what will happen. Now you can see here the earlier one, we have Rizwan here, we have Rizwan here, and new IIS has come. The name of this particular index, okay, index name is set to IIS. So you can display anything here. Let us say serial number. So I can say here serial number. Serial number. Let us run this, and you can see the serial number is displayed before this particular. This is the name of the index actually. Serial number is the name of the index. So that's why. So I can print this name of the index and see what is going to. Let me copy this. Okay, let me remove this and s dot index dot name. So if I say this one, and let me have a separator so that we can differentiate, and you can see the name of the index is serial number. So name of the series is Rizwan only, okay, but the index name we are changing it to serial number. So this has been done. Let me see. Sometimes what they do, no, they will give like this particular series, okay, and they will ask you to create, and they will give the index name here, and they will give the this one, which one, name of the series. So you have to be very careful here. S dot name. You see, first we need to create the normal series. Then you have to give s dot name equal to Rizwan. Then you have to say s dot index dot name equal to serial number, whatever the name they have given. Okay. So let me remove that index. Okay. Then let us say I want to print the data type of this. So I can say print s dot d type. Okay, d type. So that is going to print data type. So same like data type we have integer, same thing is going to print. Fine. So after this s, then we have size. Okay, let me run this. So what is the size here? 5. There are 5 elements are there. So we get 5. Okay. So then we have shape also. Let me copy this and print here shape. Fine. Shape, s dot shape. So you can see 5 comma. So we have 5 rows and only one column, since like we have data frame. Data frame will display rows and columns. But since we have only one column, it will display as it is. So I will just remove this shape. We don't require shape here now, because since it's a one single column in the series, that's why. So we have 5 elements. So what happens if we have NaN? Is it still, it is going to say 5? Just you check that one. So what happens if I say count here? Is it count is available? Count method. Is count method is there? So you have count. What is the difference between count and size? Size is this attribute. I said that one, right? So let me paste that this one here. Let me write here size. So if I say size, okay. So let me run this one. These are all attributes we are doing. Now let me remove this. Let me run this one. Both will give 5 and 5. So what is the difference between count and size? Now the thing is, you just have one NaN. How to have a NaN value? So let me take this one, this particular data frame here. Sorry, this particular series. Let me take up. Let me remove this. Okay. Now what happens if I do S3 dot, S3 is equal to S1 plus S1 plus S2. Okay. So print S3. Print S3. We are going to finish now. Just wait for we'll learn this. It's very important thing what we are doing. Now we have a series S1, S2, and we have 2 NaN values. We got 2 NaN values for S3. So we just now we have seen, right? 2 series are there. We added up. Since the indexes are not matching, so we have A here. A we don't have. Since A is not there, we get NaN for A. Okay. B is here. So 22. C is not here. C is there. So that's why here NaN, because no matching indexes here. So now if I say print, okay, let me copy from the previous thing. Okay. Let me copy both here, this side. Okay. Now this is S3. I will take S3 dot size and S3 dot, this is S3. We are finding count and what is the difference? Now you can see here, count will give 1. Non-NaN value, how many non-NaN value? 1. So whereas size will give the total elements, okay, 1, 2, 3, regardless whether it contains NaN or not NaN, we get 3. So count is the one that's going to differentiate. If there is a null value is there, it will not count that. So how many are there? Like only one value is there. So that's why we get 1 here. So that's the difference between count method and the science method. Hope you have enjoyed this particular series chapter. Thank you very much.